Hello everyone, very good morning to all of you. Again, welcome back to LNT College Multimedia Studio, Muzaffarpur. Today, I am entitled to deliver a lecture on a special and exciting topic that is actually the oxosalts, carbonates and hydrogen carbonates. So, this is the most important topics in inorganic chemistry. Actually contains two type of ions that is similar, but with reference to charge and structural composition they are different. What is the actual structural formula of carbonate? So that is carbonate anion, and this is bicarbonate anion. This carbonate anion actually contains two negative charge, while this carbonate contains one negative charge. So it is univalent polyanion and it is bivalent polyanion, right? And this polyanion actually contains more charge density as it contains two negative charge, and this is actually lower than that of the bicarbonate, which contains only one negative charge. So what is the chemistry behind these two ions? Are actually, in case of alkaline earth metals, as you know, the alkaline earth metals exist in bivalent ions, right? So this is the beauty. Actually, M, that is solid, it exists as M2 plus aqueous plus 2 electron. So because of presence of 2 plus charge, this cation, that is bivalent cation, can interact with this particular polyanion, and similarly 2 mole of, here since there is only one negative charge, so 1 mole of bivalent cation that will stabilize 2 mole of bicarbonate anion. So this is the actually beauty. And here, since the topic is oxosalts, what is oxosalts? Oxosalts means if there is a two element, that is X, which is bonded through a fashion that is X double bond O, is called actually oxo bond, right? And this is because of the two elements, so they are connected by doubly bonds with respect to the oxygen and this particular X, that is actually non-metal, where here X may be carbon, nitrogen, or phosphorus and sulfur, etc. So depending on the nature of the particular non-metals, the oxo compounds can be formed, right? So this is actually oxosalts. Oxosalts means one anionic, that is oxoanion, which is stabilized by a metal cation. Metal cation may be either univalent or bivalent. Suppose in case of carbonate, that is in case of, that is one Mg, so that is magnesium, which is actually exist as Mg2 plus, right? So what is the chemistry actually? This Mg2 plus, right? So Mg2 plus and CO3 2 minus, right? So because of the high electropositive characters, high positive charge density on this species, and because of the high charge negative density on this carbonate, so there is a strong electrostatic interaction between these two ions, right? So they form ionic compounds like that is, you can say, that is MgCO3. So that is magnesium carbonate, which contains metal, is in the form of bivalent cation, and carbonate as the bivalent anion. So this is actually, that is salt, right? So that contains actually magnesium 2 plus and carbonate 2 minus negative charge. So this is a type of actually oxosalt, right? Oxosalt. The all the alkaline earth metal actually forms carbonates, right? So that is actually beryllium carbonates. The first species, as you know, that the first species is beryllium carbonate and magnesium carbonate, calcium carbonate, right, and strontium carbonate and barium carbonates. So these are the carbonates, and how the thermal stability of these carbonates varies with the charge and size, and that we want to focus here. So what actually happens in case of beryllium carbonate, right? So this is the beryllium 2 plus. So this beryllium exists as beryllium carbonate, right? So this beryllium carbonate is actually unstable, and the thermodynamically unstable, and the instability is because of the high charge density, that is 2 plus. Beryllium 2 plus is highly charged bivalent cation, and it is also small in size, and that will distort the electronic cloud or structure of this poly anion, that is CO3 2 minus. So actually the structure of this particular polyanionic species is C double bond O, and this is O and this is O. Here two negative charge, so both will be equally distributed on these two oxygens. So here each oxygen is saturated by two bonds. This oxygen is saturated by two bonds, and this oxygen is saturated by one negative charge and one bond, and this is similarly this oxygen also saturated by one negative charge and single bond. So this is the structure of that is carbonate ion, right? So actually this particular anionic species will be stabilized by a resonance structure. So they are on the all oxygen, they are actually equally distributed in this particular structure of ions, right? So beryllium carbonate, once the beryllium carbonate is formed, the Be2 plus, right? So high charge density, so that will distort this carbonate ion. So and which lowers the bond between carbon and oxygen. So what is actually forms? Then it forms carbon dioxide gas, right? So carbon dioxide gas is formed, and the beryllium 2 plus, which is actually don't remain in the free state, they actually react with H2O to form as BeH2O whole 4 2 plus. And beryllium carbonate actually that is a salt of beryllium, so that undergo decomposition. So because of the polarization effect, so between beryllium 2 plus and carbonate 2 minus. So once this beryllium carbonate comes into the contact of water, and actually because of the polarization effect, they undergo thermal decomposition to form a carbon dioxide gas, and beryllium 2 plus as BeH2O का whole price 2 plus. So here BeH2O का whole 4 2 plus actually BeH2O whole plus. So this is overall 2 plus charge. Once they react in the presence of water, so what happens is that, so in the previous page that I have also given the actually this type of reactions. So tetra aqua beryllium ions undergo reaction with the presence of polar H2O molecule to form beryllium H2O का whole thrice and OH overall one positive charge, so that H3O positive aqueous, right? So because of presence of H3O positive, these reactions are actually gives us idea about the acidic behavior of this particular compounds. So you can simply say that such type of compound is actually acidic in nature because of the presence of H3O positive. So B2 plus here they undergo polarization of H2O. So right, so H2O actually, H2O means there is a OH bonds, and that OH bonds is polarized because of the presence of B2 plus. So polarization will actually triggers the formation of such type of compounds, that is BeOH2 ka whole thrice and OH, right? So it contains H2O and hydroxide as a ions. So two type of actually ion, that is OH2 is neutral and one is, and hydroxide is, that is anionic species. So this is the beauty of actually beryllium compounds. And what happens, all the simple beryllium carbonates, actually beryllium carbonates undergo thermal decomposition in the presence of water, that is CO2, that is released, liberated into the atmosphere, and it forms berylate ion, that is tetra-aqua beryllium 2 plus compounds. And most important thing is that that is calcium carbonate. So in this particular alkaline earth metal, that is group 2 chemistry, calcium carbonate is the most important carbonate, that is oxosalts, because of the actually the most important industrial and daily life applications in this particular carbonates, right? So once the calcium carbonate is heated, it produce calcium oxide, and that is carbon dioxide gas. And if this calcium oxide is in the solid state, that is actually called lime, once react with carbon dioxide, the product which forms, that is calcium carbonate, and the change in enthalpy of this particular reaction so gives us, that is the value minus 178 kilojoule per mole. And since the change in enthalpy of this particular reaction is negative, and hence you can say that this reaction is exothermic in nature. So once the calcium oxide react with carbon dioxide, exothermically they form calcium carbonate. So this produce exothermic reaction, right? And from this table, you are clearly seeing that the thermal decomposition or temperature of this particular series of alkaline earth metal carbonates has been provided through the reference. So beryllium carbonate undergo thermal decomposition in presence actually less than the 100 degrees centigrade. So it forms beryllium oxide, which is not exist in the nature because of the polarization effect. It rather it exists as Be2 plus aqueous. So in case of beryllium carbonate, it undergo thermal decomposition in a very low temperature, less than 100 degrees centigrade. Rather, in case of barium carbonate, that is your barium carbonate, it undergo thermal decomposition at 1360 degrees centigrade. So this temperature is comparatively higher or very higher, much more higher compared to the temperature of in case of beryllium carbonate. So what chemistry is involved here? The stability of the particular bivalent cation and bivalent polyanion. So as you know that as per Fajan's rule, B2 plus destabilizes the carbonate polyanion and undergo thermal decompositions because of the distortion of the structure of the polyanionic carbonate. So it simply in the when it comes in the contact of water, so they undergo thermal decomposition. But in case of beryllium carbonate, what you are seeing here, so that decomposes actually at 1360 degrees centigrade. So here less than 100 degrees centigrade, and here it is 1360 degrees centigrade. So there is a huge difference between these and these values. So it confirms that there is a some sort of more stabilization of barium 2 plus and carbonate 2 minus. So barium 2 plus actually this barium 2 plus, and that is carbonate 2 minus. So because of the increased size of this particular barium 2 plus, so highly charged and bigger is cation actually stabilize the larger polyanions. So since carbonate 2 minus charge is that is larger, so this barium 2 plus will stabilize this particular carbonate 2 minus to form a barium carbonate. So as you move from top to bottom, the formation of the carbonate actually increases. So because of the enhanced stability of this particular ionic compounds, right? So what happens in case of that is this is your the most important reaction. Once the calcium carbonate, so the most important carbonate among the alkaline earth metal carbonates, that is calcium carbonate. So this calcium carbonate in the solid phase that will react with two hydrogens from a acidic medium. So then it forms a calcium 2 plus aqueous, right? So and CO2, that is carbon dioxide gas, and that is H2O, that is your liquid, right? So this calcium 2 plus aqueous, because of the formation of the calcium bivalent cation, and once this calcium carbonate react with H2O, so actually they are insoluble in H2O. But once excess amount of CO2 is added in this particular mixture, then the solubility increases. Hence, there is presence of calcium 2 plus, that is calcium 2 plus aqueous, and this is 2 mole of bicarbonate ion, that is 2 mole of hydrogen carbonate forms. So because of the presence of aquated या hydrated calcium 2 plus and bicarbonate, the solubility of actually calcium carbonate increases in the presence of CO2. It means कि all the alkaline earth metal carbonates are actually springly soluble in the water. Rather, all the bicarbonates of these alkaline earth metals, they are actually soluble in water. The solubility behavior can be confirmed through these two parameters. So that is lattice energy, right? So that is your lattice energy, and that is your second thing is hydration energy. Hydration energy, right? So as you know that the hydration energy is greater than the lattice energy, right? Lattice energy, it means the ionic compounds undergo solubilization. It means they will be soluble in water, right? And reverse is also if lattice energy is very, very high and hydration energy is low, then that particular ionic compounds actually they are insoluble in water. So solubility is decided by the amount of hydration energy and lattice energy. So that can be calculated theoretically through using Kapuscinski equation or Born-Lande equation. So what happens actually here is that the in case of carbonate and in case of in case of carbonate, so suppose here that is MgCO3, and one thing is that MgHCO3 ka whole twice, right? So here Mg is common, that is Mg2 plus, here CO3 2 minus, right? Here HCO3 minus, that is univalent anion, that is bivalent anion. So as you know, in a ionic compounds, electrostatic force of attraction actually defined as F electrostatic force, that is 1/4 pi epsilon, so that is Q1 Q2 upon R square. So Q1 Q2 is the charges on the particular cation and anion. So in case of this magnesium carbonate, here Mg 2 plus and carbonate 2 minus. So overall the product of these charges will be equal to 4. So Q1 and Q2 is equal to 4. So electrostatic force between Mg2 plus and carbonate ion is 4 times to that of the alkaline, alkaline, that is alkali metal group first carbonate. In case of that is potassium K2CO3, so that is potassium carbonate, and that is your magnesium carbonate. So here electrostatic force between these two ions are very high compared to K plus and CO3 2 minus, right? Here charge is only 2 times, here charge is only 4 times. So because here Fe that is Q1 Q2 will equal to 4 times, and R square is actually R is the inter-ionic distance between these two ions. But what happens in case of actually bicarbonates, that is actually the charges is 2 multiply 1, here 2 times, right? So electrostatic force between magnesium 2 plus and bicarbonate actually 2 times lower than that of the magnesium carbonate. So here electrostatic force is low, right? So here electrostatic force between these two ions are very high. So because of high electrostatic force of interaction between these two ions, they hold together very strongly, and the dielectric constant of the water or polarity of the water are not responsible to break down this particular bond. So they are actually insoluble in water. They don't contain the magnesium 2 plus aqueous and carbonate 2 minus aqueous. Rather, all the bicarbonates of alkaline earth metals, they are soluble. So because of the presence of aquated or hydrated M plus M2 plus aqueous plus HCO3 minus aqueous, so these two ions actually remain free in the water. So these free ions actually as a result of the solubility of the compounds in water. But in case of magnesium carbonate, these two ions, actually Mg2 plus and carbonate 2 ions, does not exist in the water. So that is, they are insoluble, and solubility decreases in the group. So beryllium carbonate will be least soluble, and that will be highly soluble, but beryllium 2 plus is highly charged. So here the chemistry is somewhat different. And in case of that is magnesium carbonate, so this is actually, and this is calcium carbonate, and this is strontium carbonate, and that is barium carbonate. So the solubility decreases once you move from beryllium carbonate to barium carbonate. So barium carbonate, that is least soluble in water because of the high stabilization effect between Ba2 plus and carbonate 2 minus. Here Fajan's rule is highly effective. So they are actually sparingly soluble. But so in case of bicarbonates, so all the bicarbonates M HCO3 2, right? So that is bicarbonate, here M 2 plus and 2 HCO3 2 3 minus. So this is your actually minus. So in the particular water medium, they exist as M2 plus and bicarbonate anion. So they are all soluble in water, and solubility increases from beryllium bicarbonate to barium bicarbonates. So this is the actually chemistry. So that is, here electrostatic force is lower between these two ions. So that is why the water molecule polarizes because of the dipole ion interactions, and the ions remains in the waters. So this is the actually chemistry. And as you know that the presence of bicarbonates in the water, actually they will create the hardness to the water. So hardness is due to presence of the bicarbonate ions in aqueous medium. So what actually happens is that that is the chemistry here actually. So as you know that this is the actually calcium bicarbonate, that is calcium hydrogen carbonate, aqueous. So once it is exist as ions, since they are soluble in water, they are decomposed to calcium carbonate, that is solid after some times, and so then by liberating carbon dioxide and in the water, that is H2O. So what happens, the solubility is very high in case of calcium bicarbonate, so because of presence of calcium 2 plus and bicarbonate ions in the water. But after some times what happens actually, they undergo complete precipitation, and it is actually remain in on the bottom of the tank. So that is calcium carbonate that is formed, that is insoluble in water. So it will remain as such in the bottom of the container, right? So again, this equation actually once the calcium bicarbonate that react with calcium hydroxide, right? If you add the calcium hydroxide in the aqueous solution of calcium bicarbonate, then what happens? It forms again a calcium carbonate and 2H2O, and hence it is filtered out, and the in this way we are able to remove the bicarbonates of magnesium or calcium from the water, since the presence of these two compounds actually creates hardness to the water. And what actually happens, hard waters actually they are not very useful because they will not perform the activity here. In case of soap or detergents, actually they will react with particular bivalent cation. So here NaC17H35 CO2, that is the formula of soap, and which is also called a sodium stearate, right? So these sodium stearate undergo reaction with bivalent calcium to form calcium stearate. So this calcium stearate is insoluble in water and releasing sodium plus in the water system. So because of the insoluble behavior of this calcium stearate, so they will hamper the performance of the soap or detergents. So that is why in the practical life, in the daily life, so there should be a process by which we can remove the hardness of water through the distillations or through the evaporation in a daily life. But through by with the help of chemistry, we can also remove this particular bicarbonates, so that the soap and detergents will actually perform effectively to remove the dirt on the clothes. So this is the chemistry of soap and detergent in presence of alkaline earth metal, carbonates, bicarbonates. So this is the actually beauty of this particular carbonates. So all carbonates are insoluble in water, and all bicarbonates are soluble in water. So the bicarbonates are removed from the water, and then we can only use the soap or detergent effectively to forms, right? So this is what is the chemistry that has attracted me towards the understanding of this particular concept and ideas. So thank you, students, for listening this particular exciting topics, and I hope the chemistry involved in this particular oxosalts have attracted and refreshed your minds, and you utilized in the practical or daily life. And because of that only, here one thing that is important, that is calcium oxide. So calcium looping, right? So this is lime, and this is called calcium oxide, and calcium looping is a technology that has been used to remove the CO2 from the atmosphere. So it is the most important technology, so that is used to remove the excess amount of carbon dioxide in the atmosphere, so because of the formation of the calcium carbonate, right? So it forms CaCO3. So these limes are actually used to remove the carbon dioxide, or you can simply say this particular reagent is used to remove the carbon emissions in the atmosphere or environment, and they remediate the environment effectively, and so that human life can sustain their life on this particular planets. So thank you, students, for listening this particular topics. So again, we will meet with another video lectures, so that will be highly interesting and attractive for your brain. So thank you.